I'll just yell. All right, we're going to go ahead and get started.
Yeah, we'll get this party started.
Yeah.
Thanks for being here, man.
Yeah, for sure. All right. Hey, thanks everyone for coming. I'm Garvin. I work here at Invoca, and I'm a co-organizer of Sandweber JavaScript. Thank you all very much for coming. It's the first time we've ever tapped out on pizza, so it's really cool to have such a big crowd. But yeah, we'll have more next time.
Pizza was good.
Yeah, we got some. So yeah, a couple of housekeeping things. We have our sponsors that we'd like to thank. WorkZones, who's our normal host, PayJunction, and Invoca, and a partnership with O'Reilly Media. So if anybody wants to go to any conferences, we've got a coupon code that you can use. I think that's about it. I am very pleased to present the head organizer, Tim Doherty, today to talk about test-driven component development. There you go. Take it away.
Hey, everyone. Thanks for showing up. Before I jump, what I'm going to do is I'm going to go through like a real brief slide deck about test-driven development and about driving your components with tests. And then since I'm a glutton for punishment, I'm going to live code up here. So bear with me. But before I get started, I want to kind of just gauge the audience a little bit. How many people are using React these days? Cool. And out of those people that are using React, how many people are testing your components? That's what I thought. How many people are familiar with and/or practice test-driven development? Excellent. That's a much bigger number, a much better number. Cool. So what I'm going to do as I get into the code is just sort of talk about some of the tools and techniques that we use so that it's not all like Greek. It still might be a little bit Greek, but I'll try to tailor it as we go. All right. So why use TDD in the first place? I'm a convert. I've been doing TDD exclusively for probably about 5 years now, but it took me a couple of years. It was a journey for me. And there's some real good reasons to use it, though. I think aside from these, I think these are really important ones. The number one most important benefit, in my opinion, of test-driven development has nothing to do with any of the technical merits of it. It's a good set of tests is a self-documented, shared understanding that you've solved a problem, right? If you write tests in plain English, and you write them first, working backwards from acceptance criteria. So you have customers out there, they've got a problem. You do some discovery, you try to, as best you can, to understand the problem you're trying to solve. Then you work on acceptance criteria that tell you at a high level that you can verify that you've solved the problem. And then you work backwards from there and write out some granular tests that say, I've solved the problem. You can prove it, and they're readable, and it's really easy to understand that you've solved the problem. But they get you into this process of thinking before you write code. So I work with a lot of developers. I've been doing this now I've been in software development for my 23rd year. And one of the hallmarks I look for in a senior developer is they think before they write any code. If I give you a problem and the first thing you do is start writing code, slow down, we've probably got a problem. You're not going to solve the right problem. So writing your tests first makes you think what it is you're trying to assert. What is the expectation of this particular problem? They let you break a big problem down into small problems. The current task at hand is the current test, right? So as human beings, we're really bad at keeping big problems in our head, but we can manage smaller problems. And the other thing is that sort of plays into the brain's reward system. You write a little test, fails, you make it pass, it's green on the console, and your brain says, cool, I just got a reward. It's kind of like drugs, only less harmful, right? And then before you know it, you got a big list of passing tests. That feels good, right? You accomplish a big problem, tackle that big problem by solving a bunch of smaller problems, which, by the way, is a great way to build software. If there's anything we've learned from a number of decades in software engineering, it's that the best way to solve complex problems is by composing small solutions. And then as a side effect of testing, you get testable code, right? And testable code usually means that it doesn't have side effects, that it's single responsibility, that it is composable. So given the same skill level, two developers of the same skill level, one does something via TDD and the other just free codes it, you probably will end up with better quality code from test-driven development just by virtue of its testability, single responsibility, and modularity, and loose coupling. And then lastly, it enforces YAGNI, which is you ain't going to need it. If you're only writing enough code to make the tests pass, they should be free of cruft. There's lots of other great benefits. It makes refactoring a lot safer, but this is a pretty good sampling. So you may argue, well, I can get equivalent test coverage if I write the tests after the fact. And that's true. You can. You can get equivalent test coverage, and you can write good tests after writing the code. The problem is that if you don't understand the problem, or if you don't understand how to verify the problem, you end up with tests that verify the correctness of bad code. You know, I love this quote from Alan Holub. It just verifies that the monster lives, not that it's not eating innocent children. So with all that goodness, why not do TDD? So some of the common pushback that I get are, it takes too long. I don't have time to write tests. So it's true that writing an application, the build out with TDD can take up to 30% longer than it does without it. But it's also true, and there's lots of studies, and I can point you guys to some links offline. There's a lot of studies that show pretty much unequivocally that they reduce production bug density by 40 to 80%. And similar studies also show that fixing bugs in production is about 15 times more expensive on a relative scale than fixing them earlier in the development cycle. So that just doesn't hold water for me. It takes too long. Okay, tell me how much it costs to fix those bugs in production. Other people like to say the requirements change too quickly. If I write tests and the requirements change, my tests are all broken. Well, if your requirements change, you should be, A, refactoring your existing tests first, because it's test-driven development. If you have new requirements, you should write the tests first based on the requirements. And having a good set of tests, having good test coverage, makes refactoring a lot faster and a lot safer, right? It's really easy. If you change one line of code and your entire test suite fails, guess what? You know exactly what broke. You don't have to spend an hour debugging or trying to figure out what you broke. It makes the whole experience a lot faster. It should allow you to adapt to change faster, not slower. And then the other big pushback I get is that I don't understand the problem yet. How can I write tests if I don't know what I'm building? Well, TDD can help there as well, because you break it down into small problems and you ask questions and you do your own discovery and you answer those questions by writing tests before you write your code. It actually is a great way to evolve the design of a system, starting with the low-hanging fruit, or the opposite way, starting at the top and mocking things out lower down, and then figuring out how all those pieces work together. So you guys ever seen Mythbusters? Anyone seen Mythbusters? Busted. So why test components? We all agree that we should test our code, right? Everyone agrees we should test our code. You're not convinced yet. That's OK. But why test components? Well, how many people think CSS is hard? I do. CSS is awesome. Before CSS, I don't even want to talk about before CSS. I've been doing this long enough to know what it was like before CSS. CSS is awesome, but it's hard, right? And HTML can be hard. And combining the two is really hard, right? We spend a lot of time tweaking our UI to make it look like the mocks. It's hard enough by itself. When you conflate that with the logic and behavior of your program, it's exponentially harder. This is why separation of concerns is one of like the basic principles of software development, right? So you couple that with an environment like React, where you have your markup and your CSS potentially in your component, along with the behavior, and the need for separation of concerns is, I think, amplified considerably. So what's test-driven component development? It's basically just the idea of taking TDD and letting tests drive your components, right? So starting with tests instead of starting with code. So the red here is just write a test, a failing test, you know it's going to fail. And all it does is verify that the right data is presented and any behavior exhibits correctly in the component. Don't worry about what it looks like. Just make sure it works. Then write just enough code to make it pass. Don't worry about what it looks like. It doesn't matter. Just make sure it works. Make sure the component works. And then, sorry.
Like the business logic.
Business logic, the response to user interactions, anything that needs to happen at initialization, like any of the component lifecycle methods, and then just like the basic data is presented. Like regardless of whether it's in a div or a span or a bold tag or has the right styles, just make sure that that text or that number is there, right? And then, just like you would with any other code, if necessary, clean it up, optimize it, right, without breaking the tests. The cool thing about TDCD is then all the visual, the presentational concerns also just become refactoring. You leave your tests running, you keep them green, and then you just modify your markup and modify your CSS until it looks right. But meanwhile, you know that it works because your tests are still passing. So with that, we're going to write some code. This is going to be fun. Bear with me.
Wow. If these TV people had done tests, maybe their local dimming would work.
Yeah, well, you know, you can't have everything, Chad. All right, so what I have here is, and you guys probably need me to zoom in a little bit here. Can you guys read that in the back? Bigger? 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 Wow, really? Bigger? Bigger? Is that good? Bigger? Bigger? Still? Let me know when to stop. Bigger? We're going to run out of screen real estate pretty soon. That good? Can you guys in the back read it? Elijah, you good? I'll work with you. I'll give you one more. How's that? I can. We'll do that too. We're gonna get rid of that for the most part. Let me also bump the size on the terminal down here. Okay, cool. This is Vim. So bear with me. I'm also on a personal journey to learn Vim. So if my Vim skills are not up to par, just bear with me, okay? Like I said, I'm a glutton for punishment. All right, so what I have here is I have a Create React app, right? Create React app is a scaffolding tool to build out a fully functioning environment that has your build tooling, your test library, and everything to run a React app without having to do it yourself. And then I've added to it a test rendering library for React called Enzyme. So when you're testing React components, you need to render them. Because they have a visual component, you need to actually render them out and then make assertions. Enzyme is from Airbnb. They built it internally and then open sourced it. Super popular. It's really good. It's got some good abstractions that let you make assertions agnostic of presentation. I like it. They're a little bit behind the latest versions of React. So like there's one caveat. I'm going to use the use state hook from the newest version of React. They don't support that in their shallow render. So a couple of things still to work on, but it's generally really good. And then in order to make some kind of agnostic assertions about utility components, I've got material UI for things like a text input and a checkbox. Because what I want to do is I want to make assertions against a black box in one of my components. I don't want to have to go reach into the DOM and look for a checkbox input or look for an input field because then those make my tests brittle. I can't swap them out for something else. So I'm going to use a component from a third party to make those assertions. So we're going to build a to-do app because nobody's ever seen a to-do app before, and there are no examples out there of to-do apps. In reality, I just wanted to do something small enough that I could do it in about an hour, and we all understand what a to-do app is. And what we're going to do, another thing, like I often, when I build out applications using TDD, is I often look for the low-hanging fruit at the bottom of the tree and build those out first, and then work my way up and compose those. And until I get to the top, and then I'll write an integration test that tests them all together. I did this TDD workshop at work, and lots of people were like, well, it feels like waterfall. And how many people have ever done waterfall software development? Yeah, that's what I thought. It's nothing like waterfall. But yeah.
Real quick, you said Enzyme was the library you're using.
Yes.
Is it specifically for React components? Or
it is specifically for React.
Okay. And
yeah.
How much of that do you use? Like, how much of like, I guess you're going to go into this. So sorry, I'll let you continue.
I will. In a nutshell, Enzyme lets you render something out, and then they've got some utilities to make assertions based on what was rendered.
Like make assertions about the tree?
About the tree, yeah.
Yeah. Okay.
Yeah. So we'll get into that in a little bit. So anyway, people, and this is totally valid. people's concerns were, what if I don't know what I'm building at the lower levels of the tree? What if I only really know, like, at the top? I know there's some behaviors to happen, and I'll get detail later when requirements for the lower nodes of the tree. That's perfectly valid. Some people refer to that as discovery testing. So we're going to take that approach. We're going to build our main to-dos container first, and we're going to take advantage of the test runner library we're using. It's called Jest. How many people have ever used Jest before? Jest is also from Facebook. It is a one-stop shop test runner. It started out on a little bit shaky ground, but in the words of Ben Abramoff, who's a well-known developer at Facebook, he created the library Redux, the state management library Redux. Before Jest was good, it wasn't that widely adopted, but it's gone through a number of iterations, and it's arguably the best front-end test runner out there. And one of the things that it lets us do, it lets us mock imports. So it lets us mock entire modules that we would import. And so we can take advantage of that, and we can mock out React components that don't exist, and then make assertions against them like they were black boxes. So that's what we're going to do. So let's start with let's start by crashing things. Let's do that. Let's add a new file, to-dos, and then let's move that. And then let's add a corresponding test. And then let's start with our test, because that's what we do in TDD. OK, so I'm going to use some snippets here. If you don't use snippets or scaffolding tools, I highly recommend doing so. It saves you a lot of typing. So let's do this one. This is going to scaffold out a basic test for us, basic React test suite. OK. So you'll see here, for those who aren't familiar with unit testing, the blocks in this test are pretty common to a style of testing called behavior-driven development. So the idea being that you are driving your development based on behavior, not on implementation specifics. So Jest, which was initially built on another test runner called Jasmine, follows this idea of behavior-driven development. And so you have these blocks called describe, where you describe something you're going to test, and then you make assertions using plain English statements like it does something. Right? So here in my basic scaffold, it says it renders the component. Doesn't really do much because this is just a scaffold. And then the two other blocks you see are before each and after each. Those would be used if you need to do some setup and or teardown before or after each test. So if you need to set up your environment that your components might depend on, you do it there. You always start with a clean slate. And then if you've set something up that might bleed over into another test, you always tear down after yourself. For our tests, we don't need those. So I'm going to get rid of them. OK, so let's think about this. What does a to-do app need to do? I would say it probably needs somewhere for a user to enter some text, right? So why don't we start with that? Let's say it has somewhere for a user to enter a to-do. And let's also, yep, let's put our it back. OK, cool. So this next line here is using the shallow method from Enzyme. And what shallow does, it basically does a shallow rendering of your component, one layer deep. So it won't render out any child components. And the idea behind that is twofold. First, it's to constrain your testing strictly to the unit under test, right? So you're not worried about things polluting further down the tree. And it also restricts you from making assertions about things further down in your tree. And the other thing it does is it doesn't require any external plumbing. So for example, if you're using connected components, things that are connected to a Redux store, for example, you can typically shallow render it without the store because it doesn't actually implement the lifecycle hooks. So we're going to render this thing out. And then in order to make an assertion, what we want to do is, I mentioned material UI. We want to take another component and treat it like a black box and just say that it exists in our rendered component. Sound fair? And that should satisfy this test. So let's import that component first. and it is text field. Okay, so now, nope, you are absolutely correct. Okay, so now we're going to make an assertion. And the assertion syntax looks like this. We're going to say expect something to happen. And what we want to expect is that we can find this text box, right? So Enzyme gives you a method on the shallowed rendered wrapper called find. So we're going to say wrapper.find. And then you can pass this either a string, in which case it will look for the display name of a React component, or a tag name, an HTML tag name, or a class name, or an ID, or an attribute, or any combination of those things. In this case, we're going to make a specific assertion on the actual imported text field that we found. And the reason we're going to do that is because Material UI wraps their components in a tree of higher order components. So finding it by display name is a little unwieldy. So we want to say, we're going to look for it. And then assuming we found it, there's a corresponding method called exists that will tell us that it actually exists. So we want to assert that if we find it, that exists is true. Or sure.
You do it outside of an it block.
What's that?
You do it outside of an it block.
Can you do the expectation outside of an it block? No. Your tests only run in an it block. So let's save this. How many people think this is going to pass? What's JSLint is complaining? Oh, you are correct. That's why Garvin's subtly and tactfully telling me. Thank you, Garvin. Okay, so we know it's going to fail, right? Because there's absolutely nothing in our component file. So let's save it, and let's see what happens here. It should fail. Okay, it fails because we have what? A syntax error? Provided element type was object. That's not, so what's happening here, it's telling us that we can't render anything out because it only works with custom components, and we can't render out an object. So what's happening is this. Oops. What's happening is that Jest is smart enough to stub in something in our empty file. We created that empty to-dos file, right? Had nothing in it. And Jest is smart enough to say, they probably didn't mean to do that. Let's give them something. And so what it gives you is an empty object, right? So when it tries to import to-dos on line 7 up there, which is actually not line 7. Sorry, I have relative line numbers. Let me see if I can turn that off for you guys. Let's see, what is it? Set. Is any Vim guys in here? Remember how to turn off relative numbers? Okay, bear with me then. Yeah, bear with me then. On line 5, right here, when Jest encounters this, it says, there's a file on disk. I can do something with that, but there's nothing in it. Give them back an object. And then the shallow renderer down here is saying, I don't know what to do with an object. Help me out here, right? So let's fix that. And we can fix that like this. Let's open up our to-dos test. Okay, so we've already got that open. Let's open up to-dos. And to get past that error, all we really need to do is export a React component, right? So let's do that. I have another snippet here that will create a React component. Okay. Now, it's still failing. What's going on? Oh, we didn't save it. That's what's going on. It's still going to fail, though. Okay, now what's it saying? Now it's saying it can't find it. Doesn't exist. Makes sense, right? Because we don't have a text field in there. So let's fix that. And all we should need to do to make this test pass is to put our text field in there. passes. Cool, ship it.
So it's not checking. It's not checking that it has a child that is a text box. It's checking that it is a text box.
All we care about for the purposes of this test, and this test is not very valuable, by the way. Like we will actually subsume this with tests that actually have more value. The point here is to start small, start by failing, and build up from there, right?
I'm just confused because, like, reading the test, I would have thought that it was looking for a child that was a text box.
Well, let's look at the test and let's see what that says. Let's look at the test here. Let me go ahead and collapse this guy. Actually, we can go ahead and quit this guy.
Check the whole tree.
All it's going to tell you, all it's looking for is whether or not it exists, right? We're not asking it where it exists. We're not asking whether it exists at some level of the component or whether it's wrapped in anything else. We're just making an agnostic assertion. Is there a text field? Yes. Cool. Test passes. We're done. Okay. Like I said, that test is not very valuable, but it's a simple, gentle introduction to testing a component first, right? And of course, that component also is not very valuable for us, right? I mean, what are you going to do with that? It's totally useless. But that's not the point. We're starting out by making assertions that fail and building out from there. By the way, one thing about unit tests, if you never see a test fail, you don't know that there's any value in it. If your test always passes, how do you know it's a valid test? You have to be able to see it fail, which is one of the reasons why you write the test first, before any code's been written. And I get it. It feels wrong, right? As developers, we like to tinker. We like to explore. We like to take a problem and see where the code takes us, right? And then later, maybe, if we're conscientious, or more likely, if someone makes us, we write tests, right? So it feels wrong. I get it. It takes time. It's a paradigm shift. Anyway, this is not a very valuable test. Let's add a test that's maybe a little bit more valuable. Why don't we say that when it initializes, if we pass it some to-dos, it should render something. How about that? That sound like a reasonable test? Because while we might pull this thing up and always force the user to type in their to-dos, in the real world, if you had a to-dos app, you probably want to maintain that list of open to-do items or even completed to-do items. So let's say that when we pass it, yeah.
So, you switch off that, the character display.
Which character display?
Is that a new line on tab or whatever?
Where, which?
After a semicolon, there's some weird.
Right here? It's a white space character. It's in my vimRC. If you can deal with it, I'd ask you to just bear with me. Thanks. Cool. Because I don't remember what the flag is. Otherwise, I'd just pull it up and run it in command mode right now. Again, like I said, I'm learning Vim, guys. Bear with me. That's another illustration of my gluttony for punishment. But I am starting to see a little bit of return on investment on it. All right. So let's write that test. Let's say it initializes with a list of provided to-dos. Okay, so let's go ahead and render it out. And let's create a list of to-dos. And what we'll use here for our to-dos is a map. Why are we going to use a map? Who's familiar with the ES6 map data structure? Anybody not familiar with the ES6 maps? And how many people work with JavaScript? Okay, guys, it's 2018. The spec was finalized 3 years ago. Get with the program, man. No, in all seriousness, we got a couple of new data structures in the ES6, and they were maps and sets. And they're similar. They're related. A map is basically a set of key value pairs. And the only real difference between it and an object is that you're guaranteed iteration order. The order in which they're inserted is the same order they'll always be read, where the iteration order of an object's keys is not guaranteed. And then you also get these nice shorthand methods, get and set, that let you just get something by value and set something by value, and it's guaranteed to overwrite the previous value. We got a little indentation issue here. Let me fix that real quick.
And you grab anything for the key.
What's that?
You grab anything for the key in a map.
Yes, a map will take. That's right. A map is heterogeneous. It'll take any key and any value for any entry. That is absolutely correct. Let me just fix this indentation here.
Map literal.
What's that?
There are no map literal.
You have to say new map in order to.
I don't think there is a map literal yet. I could be mistaken. I don't think there is. Okay, so let's create our new map. But what you can do, though, is you can populate a map with any data structure that implements iterable. So in this case, we can pass it an array. And it's going to be a two-dimensional array. So let's say we have a value called foo. And its initial value is going to be true. Sorry. No, we'll make it false. We'll initialize it as false. And then let's create one called bar. And we'll make it true. So basically, the strings are the keys in our map. And a to-do item is either done or not, right? So it's always going to start as not done, and then you're going to check it when it's done. So there's our to-dos. Let's pass them to our component.
You could say that a to-do list is a list of strings.
Or
like an array of strings, or like a set of strings. So why did you choose?
You could, but then how would you know whether an individual item is done or not?
Oh, right.
Right.
Then you'd only have like the queue of things you have to do, but you wouldn't have a
Right.
record. But
So you could make it an object, and you could add keys to it with the value false. You could make it an array of objects with a key and a value. This gives you sort of a nice little shorthand.
I guess so
for it.
my question is that you're starting to gel on an interface, and that's okay, right? Like,
I'm making an assumption based on the data structures that are available to me in the language, right? So like I have a problem statement. I need to store a collection of items, and they need to have some sort of a key, and they need to be either done or not, right? Okay. And so based on my knowledge of the data structures that JavaScript gives me, I'm going to reach for map. Map is the most natural choice for this. Regardless of how I build the rest of my to-do app, where I'm going to store my data, a map to me makes the most sense.
I was just trying to understand how you decided that was going to be the interface, but that makes sense.
No, it's a fantastic question. And in fact, I did an exercise similar to this at a lunch and learn at work, and I purposely started with a more naive implementation, which was an array. The array was an array of objects. And then you had to do things like array.find, where you went in and give it a predicate that says, look for the key and look for this key name and update it. Whereas a map is much easier. You just do get, right? Get by the key. So there's things that a map gives you that make it a natural choice. The data structure here. Okay, so we're going to pass it this list of to-dos. Now, where are we going to display these to-dos? How are we going to know that we initialized right? We probably need something in this to-dos container that renders them out, and we give it that list or that map as props, and then we can make assertions about that. So we could have like a to-dos list, right? We haven't built that yet. Jest to the rescue. We can mock it. We can create a to-dos component that we haven't even yet, and we can treat it as a black box, and we can just make assertions about its public interface. So let's do that. Let's start by creating that. Jest does need a file on disk, otherwise it's not able to create it. So let's do that. Let's add let's call it to-dos list, or we'll call it to-do list. How about that? To-do list.js. That should be all Jest needs in order to be able to import this file. So now what we can do is let's import that guy. And then what we need to do is we need to mock it. We're going to tell Jest that you have this thing, there's nothing in it, but we want to pretend like there is something in it. And we saw earlier that if we just have an empty file and we try and import it, React can't do anything with that. And in fact, Jest, even if we tried to just mock it without providing an implementation, it would still just return that empty object. And the shallow renderer from Enzyme just chokes on that. We saw that choke. It doesn't know what to do with an object. So what we can do is we can provide it with an implementation, which is a bare bones React component. So the syntax looks like this: jest.mock, and then you provide it the module identifier, which in this case is the path to it, to-do list. And then we'll tell it, and by the way, we want an implementation as well. And that implementation, so you provided a callback function that will provide the implementation. And in our case, we want to provide it with a React component. And a React component looks like, oops, a basic React component. We can just use an arrow function and return like a div, right? That should suffice. That should be enough to mock out a React component. For those not familiar with React, there was only a handful of people in here that used React, right? Can I show hands again who's using React? All right, so some of this is going to be Greek to you. React in a nutshell, let me see if I can succinctly describe this in like a sentence or 10. React is just a view library. And the basic idea of React is that you can build a component tree. You can build a UI as a tree of components. And each of those components renders out content via a pure render function. A pure function just means it has no side effects. And given the same inputs, it always produces the same output. And it has this nice little language extension called JSX, which is JavaScript in XML. So you can express functions as XML, and it looks a lot like HTML markup. So what we're doing here, the React component itself is just, let's see, it's just this right here. Just a function that returns some JSX. That's the React component. Does that make sense, everyone? And then the only other thing that you really need to know about React is that in a React component tree, so let's say you start with the top of your tree and then you build out a bunch of leaf nodes, right? Data only ever flows downwards from a parent node to its children. And those children, in response to getting data, which we call props, properties, when they get new props, they will re-render. And then there's also stateful components. And I mentioned that because we're going to use one. And a stateful component can also hold its own state. And then it has a method, a built-in method, that lets you trigger a state change. And the component will also re-render in response to that state change. That's pretty much it. That's React in a nutshell. There's a lot more that goes on under the hood, but that is why React is important. In my opinion, the one-way reactive data, that idea of having your data always live higher up and flow downward and have the leaf nodes respond and react to that is kind of the most important thing that it's popularized. Not a new idea, but popularized by React on the front end. All right, so we have our mock component, right? So now we can pretend that component is a real component. Why? Because we don't care about its internals. In fact, this test should not make any assertions about the internals of a child component. We're testing this unit, the to-dos unit. So this suits us beautifully. We can now assert against the public interface that it has. In other words, it's props, right? And then we can verify whether we actually passed it the right props. So what we're going to do, and let's make this full screen so we have maximum real estate. So we've passed it some to-dos. Now what we want to do is we want to assert that when we find that to-do list, that the props match, right? That should be enough. If we just say that it's got a prop called to-dos, and it's recursively equivalent to this data structure, we should be good. Everyone agree with that? Anyone not agree with that? Does that sound like a reasonable test? Cool. I'm asking you guys to poke holes in it. This is an interactive experience. Okay, so all we need to do is we're going to say expect again. And we can use wrapper.find again. That will also help us here. Wrapper.find. And let's find our to-do list. And then what we can do, Enzyme provides on both shallow and there's another one we'll look at in a minute called mount. It gives us a utility method called prop that lets us find a named prop. There's a plural form called props also that will get you all props, which is also useful. And let's just go ahead for consistency. Let's call the props the same thing, to-dos. So we want to find this to-do list and we want to grab its to-dos prop. And then basically we're just going to assert that if we do a structural equivalency on it, that it is the same object that we passed in. And let's say we're going to use a method called toEqual. And we want it to match the to-dos that we passed in. Okay. And what we should see is that it fails. So it can't find it. What did we do wrong? We did call it to-do list, right? Oh, we didn't make a path. We didn't make the path correct. Let's fix that. That should get us past that specific error. Okay, now it's telling us that it can't find it. What it's actually telling us is that the method prop is meant to be run on a single node, and we didn't find that node. Because we made an assertion about this to-do list, but it doesn't appear in our component yet. everyone get that? So let's make it appear in our component. Okay, so we're going to need to import it. Okay, and now we are going to need to wrap this in something. I am using React 16.6, and the newest versions of React actually will let you return more than one top-level node. In previous versions, you had to have a single top-level node. We're going to, for simplicity's sake, we're going to respect that, and we're just going to wrap this in a single node. This is a little plugin called Surround, Vim Surround by Tim Pope. And then let's wrap the whole thing again. Okay. And then what we can do, oops. Now we can render out our to-dos list. And then we just want to pass it our to-dos that we passed in. And that should be enough, right? Our assertion was that we find a component called to-do list and that it has the same prop that we passed in. Yeah? We failed. Oh, we got that same path issue. What's that, Max? Yeah, this just needs this.
I think initialize is misspelled somewhere too.
Yeah, it could be. But that shouldn't cause our test to fail, right? It passes.
Yay.
Ship it, right? Look at that. Now we have like more tests passing. I don't know about you, but my reward system's kicking in here, man. Like I want another hit. All right, cool. Good. So now we have 2 tests, right? But still, this is not a very valuable component. Still not doing a lot for us, but we're getting somewhere, right? We've made a couple of assertions. We've started with these assumptions, and we've made them pass. Any questions so far?
So, are you going to show the browser?
You know what we're going to do? We're not going to look at the browser until we're done. You know why? You know why? Because what did I say in the slide deck? We can actually verify the behavior and the data that a component displays and all of its interactions without ever looking at it. And in fact, we want to do that, right? Why? Because otherwise we start going down that rabbit hole. Oh man, it's halfway working, but man, that class doesn't look right. I got to move this 3 pixels to the right. Oh, an animated fly-in would look amazing here. Let's make it rotate. How many people, because we've never done that, right? No one's ever done that, right? So the whole point here is we're going to be disciplined and we're going to verify that this thing works. And in fact, I just ran through like a Dev Academy at Procore. We do these in-house learnings. I ran through a 3-week Dev Academy class where we built out a YouTube player and we built the whole thing without ever looking at it in the browser. And then the very last day in class, we stood up in a browser and it looked like shit, but it worked. And then we spent
for a while. You can pretend you're not a web developer.
That's right. You can pretend you're a software engineer. Right? All the back-end developers in the room loved that one, didn't you? Yeah.
I didn't know this for a long time, but just kind of a tip. You don't have to wrap it in a div. You can use React.fragment.
So that's what I was mentioning. That is new as of React 16. React Fragment is a new thing as of 16. And so again, like for simplicity, so as not to introduce too many new concepts, I just kept it in a div. But you're absolutely right. React Fragment basically allows you to return multiple top-level child elements. There was a way to get around that also in previous versions of React. You could actually have a component return just return an array and then use that as the children of a surrounding element. But I digress. So yeah. Anyway, in that class, we spent the last like 2 hours in the last session just doing visual refactoring. We had the tests all passing, and then we started adding CSS files, and we started moving things around and switching out tags, and it was badass. It was really cool. All right, so, but again, this component is useless at this point. Let's go back to our test, and let's write some more tests. So we've got a text field where a user can enter something, and we know that if we pass it some to-dos, it passes it down the tree. What else do we need to do with this? We probably need to be able to add one, right? To-do list is pretty useless if you can't add a to-do item. So why don't we write a test for that? Let's do one. Let's say that we want to let's say it adds a new to-do. How about when the user presses enter? And let me make Chad happy as well. There, fix it. Okay, so now what do we need to do? We're going to need to put some stuff in that text field. And then we're going to need to press enter. And then we're going to need to verify. We'll start out with an empty list or an empty map. And then we need to verify that there's something in there that matches the value that the user entered. That sound good? Why don't we put that in comments? Let's say initialize or render with no to-dos. And then enter some text. Press enter. Check if it was added. Sound good? Cool. So let's do this first part. Okay, so we're going to need to find that text field. And since we need to do two things with it, first is we need to put something in it, and then we need to press enter. Let's get a reference to it. Instead of saying wrapper.find twice, we'll just get a reference. Let's say const text field equals wrapper.find text field. And then we can make some assertions against that wrapper that was returned. So what we want to do is there's a method called simulate that Enzyme provides for you. So React abstracts the DOM for you. Everyone knows what the DOM is, right? Everyone that's working on the front end knows what the DOM is, right? And everyone knows that it's a really unwieldy API to work with. It's better than it used to be. We can thank jQuery for that. In general, the golden rule for web developers is don't touch the DOM, right? Not only because the API is unwieldy, but because changes to the DOM are the most expensive thing you can do in the browser from the UI perspective, from a rendering perspective. Anytime you resize something, reflow it, move it in the document, right? It causes a repaint and a reflow of the entire document, and it's expensive. React gets around this for us by having a reconciliation algorithm. They call it virtual DOM, which is a really fancy name for a change diff, right? They basically, in memory, they keep a copy of what the DOM would look like before you did something. Then you change something and it says, only this, this, and this change, and it only updates those things for you. That's also kind of an important thing that React gives you, but not as important as the one-way reactive data flow. So it gives you a bunch of tools that let you reflow and repaint a component tree without ever touching the DOM. So likewise, in your tests, it's generally better to not touch the DOM. And it's generally better to not make assertions about the DOM, because if you do, your tests are brittle. So for example, if you say that find a div with an ID named whatever, what if you want to change that to a span or a section or a header or an aside? You can make less brittle assertions. There's an exception case here, and it just has to do with the specific implementation of text field. What we really want to do, anyway, bring it full circle. The event handlers that you attach to DOM elements, React kind of sidesteps that and gives you synthetic event handlers. So when you give it an on-click handler, it basically wraps that, and then it traps the actual event that happens, and then bubbles it up to your event handler. And Enzyme takes advantage of that by giving you a simulate method, which doesn't touch the DOM at all. It just calls your callback, right, with the expected event. Normally, we would just be able to simulate the change event. For some reason, the text field at Material UI, with all of its higher order components that it wraps, it doesn't work. So just a caveat, we're going to have to circumvent that, and we're just going to call the change function directly, just as an aside. So we're going to do that right now. We're going to do text field, and we're going to find a prop called change. Actually, let's do it like this. Invoking functions is, I think, a little bit clearer semantically if you just grab the props object and then call the function. Alternate, it would look like this. We would do prop on change and then call it. It works, but it's a little clunky looking. I think it's cleaner to do something like this. Oops. Oops. That looks better, right? I think it's just a stylistic choice. Doesn't really make any difference. And then the change handler for a DOM element, you get an event, and that event has a target. The target is the DOM element that spawned the event. And in the case of a text field, that target will have a value property. So we're basically going to simulate that. We're going to stick we're going to stick an object in there that's going to represent our event. And we will give it a target. And that target is going to have a value. And so we can make assertions about it. We'll create a variable called to do and assign it to that. Let's go here and say, do the thing. Okay, so we're going to simulate the change, and that should put a value in our text field. That's the first part. We're going to pretend that the user typed something in there. So there's our enter some text. Okay, then we're going to simulate pressing enter. Now, ironically, simulate works on key up. Don't ask me why, materially why I implemented that way. Why key up? We definitely don't want to add a new to-do every time the user changes something, because that means every time they type a key, we'd get a to-do for each letter in the alphabet that they changed, right? So instead, we'll trap the key up event, and then we will look for the enter key. Make sense? Let's do that. So simulate takes the same signature, you give it a name of the event, and then you give it whatever the event would be that you're passing to it. So we're going to simulate key up, and then we're going to pass it an object. And in this case, it has a key property. And this, by the way, just comes from DOM. This is not React. And the nice thing is, you used to, in the old days, you used to have to check for the key code, for the ASCII key code. So you had lots of code that said, if the key code is 13, so there's an improvement in the version 3 of the DOM API. You can actually look for a key property, and they have names for the special keys, like enter, which is a lot cleaner.
This is injecting the event.
What's that?
This is injecting.
That's the argument. So simulate says, simulate a named event. In this case, we're going to simulate the key up event. And then optionally, you can pass it the event that it should pass to your event handler. So in this case, we're going to simulate a key up, and we're going to pretend that the key that was pressed and has been lifted up is enter. Okay, so there's that.
That's a method of wrapper.
Simulate is a method on the enzyme shallow wrapper. That's correct.
Oh, yeah.
Yep. Yep. Exactly. Yep. And now we're going to check if it was added. So now, what we probably want to do is just to make sure that our to-do list has nothing in it first. So ideally, we'd put an assertion there, but we're going to leave that implicit for now, since we did not initialize it. We're going to assume implicitly that there are no items in our to-do list. So let's do this. Let's find our to-do list. Let's expect that our to-do list at wrapper.find, and then let's assert about its to-dos property. And then map has a property called size to check the size of it. And we expect that it should be 1. Okay. And it's going to fail, right? Does anyone think it's going to pass?
Because you've only added one key.
Well, we don't have a change handler, and we don't have a key up handler. So we know it's going to fail, right? But that's the point. We want it to fail because we're doing this TDD. We're writing a failing test. So it's telling us exactly what we expect. On change is not a function. We don't have a change handler. let's fix that. Okay. So let's open our to-dos and let's implement that. So onChange is going to be a function, and it's going to take an event. And from that event, we are really only interested in the value, right? So we're going to use ES6 destructuring assignment to tease that event apart. And what we really are concerned about is just this value property on the target, the DOM element that triggered the event. Now, we have a value. Where are we going to put it? We're going to need to put it somewhere, right? We probably should hold on to it because in our key up event, we need to do something with it. And for that matter, we're probably going to also need to store our to-do list. So at this point, we're probably going to have to reach for some state to hold this stuff. Now, in the old days, last month, those of you who work in the front end will appreciate that. In the old days, in React, we used classes. JavaScript does not have classes, by the way. JavaScript has syntax sugar on top of constructors and prototype chains that emulates the semantics of classes, but they're very different things.
New JavaScript has classes.
It does not have classes. It has a syntax called classes, but if you look at the spec and how browsers implement it, all that is syntax sugar on top of constructors and prototype chains. It's literally just syntax. JavaScript does not have classes. They have classes, but they're not really classes. And anyone that has worked in a class-based object-oriented programming language like C++ or Java or C# can attest that classes in JavaScript don't work the same way as class-based. What we have is prototypes and constructors. In the old days, last month, you had to reach for a class that extended from the React component prototype. And it gave you things like this.state and setState, which let you hold state in a component. So there's a library out there. How many people are familiar with Recompose? Anyone used Recompose before? The library out there called Recompose, and it's like a functional tool belt for React. And it was so successful and so popular that Facebook hired the guy that wrote it. His name's Andrew Clark, and brought him in-house and put it in React. That's what they basically did. Not all of it, but lots of stuff from Recompose is now in React, and they're calling it hooks. And what they are is they're hooks into things that otherwise would be provided by the React component-based class. Things like state and side effects. And there is a reducer pattern that lets you, if you need complex state transitions, you can actually use a switch statement like you would in Redux. And basically, you can declare these things in a pure stateless functional component. And then you use them without the overhead of classes. So I thought it would be a kind of a novel there. That my colleague tells me that 16.7 was released. I missed the beta announcement. This is an alpha version of React, but I thought it would just be novel to throw in the use state hook. And so the semantics of it look something like this. Let's grab it out of React first. It's all of the hooks use semantics like use something. In this case, we're gonna use state. And that basically lets us hook into externally managed state that will be preserved in between calls to this function and pull that information out. So we're gonna grab use state. And then the way it works is you declare the value that you want to read from state and a function used to update that state. And you grab that back with a multi-value return from the function inside an array using destructuring assignment. So we'll call the state that we want to maintain to-dos, and we'll call the function something really descriptive like set to-dos. And that's going to be use state, and you can then provide it optionally a default value for your state. So those of you who have used React.component, this would be the equivalent in your constructor of saying this.state equals some property. And so in this case, since we have a test that verifies that we can initialize with a past set of to-dos, we probably should respect that. So why don't we say that if they pass us that, we'll use it. Otherwise, we'll initialize with a new map. Okay. So this is going to give us, this is going to allow us to persist the value of state for to-dos between function calls. This is just a function. Okay. So now we can, instead of rendering out props.todos, we'll just render out the state that we already have.
Roads, semicolon.
Where?
On 9 function at 9.
I meant to put that here. Thank you, Garvin. Okay, so now we have somewhere to store our to-dos. That doesn't help us with our current to-do, our text. So we probably want also to store that, right? So let's do a handler for our current. Set current to do equals use state. And we can just initialize that to an empty string. Okay, so now what we can do in our handler here is we can, let's just do a check to make sure that there's something in there. If there's something in our value, which there probably is, but it's possible they just hit enter with nothing in there, right? Then call our state updater. Set current to do with the value.
This may be a naive question, but you have not value.
Yes. So that is a double negation. JavaScript has a Boolean primitive, but it also has a concept of truthy and falsy. So imagine you're in Vegas and you're dealing with some shady character and you're lending him money and you say, you're going to pay me back, right? And he goes, yeah, truthy, sure, right? It's kind of like that. JavaScript basically, it treats any non-empty string, any non-zero number, any non-null object, etc., as truthy. And it treats empty strings, zeros, and nulls, and undefined as falsy. So which means you can construct logical operands on either side, right, with truthy or falsy values that will equate to a Boolean value. What we want to do here is we're basically saying, try to negate it, right? And in which case, if you say not on an empty string, it should be true. It should be false, right? And then you can negate it again. Sorry, that will be true, and then you get false by negating it again. Or if it was a Boolean, for example, and you said not the Boolean, that would be false. Negating it would be true. So in this case, we want to check that it's a non-empty string.
I guess so it's not different, just value.
You could, yeah, you could do that too. That would work as well. Let's do that. That's simpler.
Yeah, because it's like you're pressing it down to a Boolean. You're like doing a cast to a Boolean in a certain sense.
Why? Because that's more explicit.
Okay,
right?
Yeah, cool.
If some absolute Boolean value.
Yeah,
But that's totally valid too. Let's just say if value, right? This will be legit as well.
People have to be able to enter 0.
What's that?
People have to be able to enter 0.
Yeah, there you go. Exactly.
Tim, did you actually enter text in your in the test?
Yeah, I don't think.
I thought you just pressed enter.
Yeah.
No, we didn't. We actually didn't press enter yet. Let's go back to our test. I think all we did, no, right since last year. Oh, let me write that. Sorry. I think all we did, no, we did. See, we did the props on change right here, and we passed it this constant to do.
Oh, got it. You had to do the thing.
Yeah. Okay. So I think at this point, so we're still not there yet, though, right?
Okay, so you're not simulating key presses into the text field. You're just kind of like putting data in there.
So what we would do in an ideal world, if the text field for material UI actually respected simulate and change, and in fact, it might in shallow. But there's a hiccup here because I'm using hooks, and the enzyme library is a little bit behind the rogue folks at Facebook. Shallow doesn't respect hooks yet. So we're actually going to have to change these tests to be mount. In fact, we're probably going to get a, if we go ahead and look at this guy, we're probably going to get a warning saying that you can't use state, is my guess. because shallow doesn't recognize it yet. Yeah, hooks can only be called inside the body of a function. I discovered that as I was trying to figure out what was going on here, and it turns out there's an open issue on enzyme. But it's okay. We can get by in this demo by just using mount instead. And I'll tell you in a second what mount means. First, let's just fix it. Okay, that should fix that specific problem. It'll fail otherwise because we don't have a key up, but you see that went away, right? What's mount, you ask? Somebody ask it, please. Thank you. Mount is the other render. There's 3 render functions that are given to you by enzyme. Shallow, as I said, just does unit rendering. It renders 1 level deep. Mount actually uses JSDOM, which is a library that provides a full emulation of the DOM for you, and it actually stands up your entire component tree. In general, I recommend using shallow for just about everything until you can't use it anymore. There is an extensibility of shallow. You can render out, you can go down the tree one at a time by calling dive on the returned wrapper, and dive does a shallow render 1 level deeper. And there's some use cases for that. And there's even like a dive until, where you can dive until some predicate is true. I recommend that when you get more than like 2 or 3 levels deep diving, take a step back and ask yourself what you're trying to test. Chances are you're going deeper than a unit test, right? If for some reason you are using a third-party component that, say, takes something you give it and wraps it deep in a child, like in higher-order components, there may be legitimate use cases for mount. And the other thing mount is really good for is integration testing. So one of the things I often do, once I have all my units built, then I want to verify they all work together. So I'll use mount, and I'll stand up all the plumbing it needs, including a fully functioning Redux store and everything that I might need. And then I'll start critical pass through the application, make sure everything behaves the way it should. I'll stub out API requests. Mount is really good for that. There's one last render method that enzyme gives you called render. And render renders out an HTML string of what the tree would look like. So you can make assertions against what the HTML should look like. All right, in our case, we now have, let's get rid of this comment. We don't need that anymore. So we now have simulated the change event, and we've simulated the key up event. The only thing we're missing now is a handler for that key up event. And in that handler, we just want to add that new to-do. And that should make our test pass, right? So let's go ahead and implement that. Okay, so if we just add an on key up, and it's also going to take an event, and we're going to pull that event apart. We could, of course, just destructure the event in the function. I mostly steer clear of that pattern for personal reasons. It's a stylistic choice, and I usually do it here. I especially do that in React components. You will see lots of React components. If we go back up here, you'll see lots of React components where they just use either arrow functions and or destructure the props that come in. What I find time and time again is when I'm trying to debug, I'm looking for props anyway. So I always just take props in and then destructure it if necessary on the next line. Again, stylistic choice. But Dan Abramov actually tweeted that recently, which kind of vindicated me. He said, unpopular opinion, arrow functions and destructuring are wildly overused in the React community. All right, so let's pull that apart. And what we're looking for here is just that key. And we can actually just do that, I think, should do. Pull that out of event. And then we can just check if it's enter. If key equals enter. And let's just to be safe, let's just also, actually, I think it's uppercase. Oops. Just to be safe, let's just check the value again, just to be sure. And then if those things are true, and I know Dylan is sitting back there going, if you had Elm, you would never have to have those kinds of checks in your test. And you're right. You're absolutely right. But if those things are true, we can then call our set to-dos. Actually, what we'll need to do first, since this is React and immutability is key, I think what we'll do is we'll make a copy of our to-dos. before we mutate it. Sound reasonable? Rather than mutating. So props are supposed to be read-only.
Why value instead of current to do?
You are absolutely correct. Thank you, sir. I think I had a previous implementation of this where I had read the value directly from it. Thank you. Appreciate it. All right. So props are supposed to be read-only. And in fact, if you try to reassign anything in props, React will scream at you. But you can change the values inside complex data structures. But you're not supposed to do that. That's bad. Mutating the props is bad. Remember we said one-way reactive data flow? The data only changes at the top of the tree and passed down. So, so what we'll do is we'll respect that. In fact, we'll even be clear with our assignment. We'll make it a changeable variable. Let's say new to-dos equals, and we can just do this. We can create a new map and pass it the old map, and it will copy that for us. Okay, and then we can use the nice syntax that map gives us, and we can do dot set and give it the string, which is our current to do, and we will always initialize new ones to be not completed.
Won't that actually not make a deep duplicate?
As far as I know, it makes a copy, not by reference, by value. But I could be mistaken. Please, somebody go look it up and get back to me and tell me if I'm actually mutating things, because that would be bad.
If it's all immutable, it doesn't matter if you make a shallow copy or deep copy.
It's not, though. Immutability is not enforced by React. So, for example, the same thing is true of the const keyword here on line 23, where we say const. Const is just a mutable assignment. Well, it means that you can't reassign the variable. But for anything other than a primitive, you can change its value. So you can mutate an array or an object or a map, right? It's more like a signal of intent than anything else. As far as I know, you can mutate the value of complex types passed as props. And so what we're trying to do here is to avoid that, but I could be wrong. I can be and am often wrong. That's actually the two most important things I've learned in 2+ decades of software engineering. I don't know, and I'm wrong.
Or you could use Elm.
Or you could use Elm. Or shit, man, you know, we now have class, we have private, static. Now we got TypeScript. They used to say that Java is to JavaScript like cars to carpet. I'm not so sure anymore, man. Seriously. We could all just use Java and transpile it to WebAssembly. Right? Seriously. All right, so we're going to go on the assumption that we've just created a copy by value, not by reference. I could be wrong. And we're going to pretend that for the rest of this exercise, okay? Just bear with me. All right, so now we have our copy of to-dos, and we've just added something to it. Now we can use our state mutator and set the value. And we'll set it to new to-dos. And what that's going to do, that's the equivalent of calling set_state in a class that extends from React component. That should then cause the component to re-render. Now, there's sometimes a little bit of a caveat. Not anytime, but a lot of times with state mutations in React components, the renderer, the enzyme render doesn't pick up the change, and you have to tell it to refresh. So we may need to do a wrapper update. Let's see what happens. Let's save it, and then let's see what happens with our test. It worked. Cool. Ship it. You guys starting to see where this gets fun? You know, the cool thing about this, like, I spent years and years and years writing features and then having a manager say, or like a dev lead or someone say, dude, there's no test coverage. The test coverage threshold dropped below 73%. Where's the tests? Writing tests after the fact sucks, man. It's a chore, right? It's something you have to do. The cool thing about doing it this way, this is actually fun. Once you get into the habit of doing this, like solving the tests is just as much fun as solving the application code. Yeah.
Even worse, you have a manager who says, no, you need to get on to the next thing. And
yeah.
Like, dude, I need to write at least a couple.
Yeah, well, and then the other person to be aware of is the manager that says 100% test coverage. We will settle for nothing less than 100%. Now, in all fairness, if you do test-driven development, you probably be pretty close to that anyway. You'd probably be somewhere in the 90s. But that's like 100% test coverage is like a unicorn that doesn't really mean anything, especially if you're in a statically typed language, right, where you have lots of boilerplate for your POJOs and whatnot. If you're testing that a plain old object has the properties you defined in the scaffolding boilerplate for that object, that test is totally useless. And your type checker will probably catch that anyway. right?
Also,
So anyway,
certain
I digress.
couple error checkers don't even know how to make error happen.
Yeah. Anyway, I digress. Okay, so we now have, let's go back to our test.
This last test you wrote,
Yes.
is checking if you can insert a to-do item into an empty.
Correct.
I suppose you might write tests that are similar to that. Like, for example, if you already have a list and you add an item, click that increase.
Yeah.
Is there any way to reuse the test and kind of abstract away?
Absolutely. 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 You definitely can do that. And especially when I get to like integration tests where I have to, where the results of a further along test rely on steps I've already done, I will write helper functions, right? So with my YouTube one, I wrote a search helper that would go find the search bar, enter a search term and hit enter. And then in my subsequent test where I wanted to verify that that not only was a list of results there, but I could click one and it would become the current video, I called my do search helper first. Yeah, you can absolutely do that. In fact, like one of the things is here we're doing these simple mount calls where we're just passing a prop or two. In some cases, your component may take lots of props and they're all the same for each one. And you don't want to have all that boilerplate in every test. So you can either have a variable that can be reassigned that lives higher up here, like at the beginning of your describe block, and then have a before each block that renders out, that has all the dried up rendering code. Yeah, you can definitely do that, and you can write functions that will make assertions, right? Just be careful, right? Tests are the one place where a dry doesn't always apply, right? Especially when you deal with like setup data or data under test that can be mutated, because you can have false positives and negatives because you don't have a clean slate. So yes, you can, and if you're doing things repeatedly, you can definitely dry it up, but make sure you do it in a way that you always start with a clean slate and always tear down after yourself. Make sense? Cool. All right. We've got a text field. We can initialize a list. We can add something to the list. We're getting somewhere. This is like a partially functional to-do app at this point. We can add a to-do item. We can't complete it, and it doesn't actually even show up because the to-do list item is just an empty div. But we're getting somewhere, right? We have something. All right. So what else does our container component need to do? What else? Like if you have a to-do list, what else might you see? Well, we're not there yet. We're not there yet. We're going to get there. That'll be down deeper in the tree. We don't know that yet. Our PM hasn't told us the requirements for that part yet. But we know that we have this top level thing that has a to-do list, and we know we can add something to it. Do we always want to see all of them? Sometimes we only want to see the ones that aren't done yet, or we want to know what we've done this week or to this point in time. We might have a whole bunch of shit that's done, and we don't care about those anymore. We want to get rid of them, right? So let's build some of that out. How about we want to only see the active to-dos? How about that? Sound like a good test? Anyone not think that's a good test? I think it's a good test.
We could write a test that says don't display the ones that are finished, and then that one would just pass. Because we're not displaying anything.
What if we, well, not really. Because what if we pass it ones that are, what if we pass it a mixture of both?
Well, that's
right?
What I mean. Like right now, we're not displaying any list, right?
Mm-hmm.
So if we say don't display these ones that are done, that'll just pass.
Yeah, that's fair. You'd want other tests to negate that one. But here's the thing. If you write, like I said earlier, if you write a test and you never see it fail, it's not a valid test, right? So if you write a test and it's green and you know you haven't implemented the thing that it's testing, that's a red flag, right? Make sure your test fails. But why don't we write a test that says it only displays the active ones? And then we can write a related one that says it only shows the completed ones. Yeah? Sound good? Cool. So let's do that. It only shows active to-dos. Okay, so let's go ahead. Let's see, I think I have a snippet for mount as well. Let's see. Let's find out. Maybe not. I guess I don't. Let's just do this then. Let's go ahead and let's grab these two lines. And that way we can render it out with at least one that's active and one that's not. So not a very good sample size, but it's enough to validate the test. Yeah. And then let's do this. We're going to need something to be able to toggle those views. I just happen to know that there's something in Material UI for that purpose that we can use as a black box. It's called bottom navigation. Put it at the bottom. And we get some actions in there. We can click them and change the state. Sound good? In theory, in concept, it sounds good. Okay, cool. Let's do that then. Let's bring it in. And it consists, in fact, let's see, do we even need to import it here? I'm not sure that we do. I don't think we do. So we can just do this one, we can assert against display name. That'll be good enough. Let's do this. Let's do, and I just happen to know the internals of this. In fact, if it's helpful, I can pull it up and we can look at it. That was cool. Infinite recursion. Where's my browser? It's right there. Okay, hold on. Let's do this. Material UI. Bottom navigation. So it looks like this, right? You got some things at the bottom that you can click. Basically just sets a value, right? And then we can hold that. Our values can be like active, completed, and all, right? And it looks like this in markup. You basically have this container, this bottom navigation container, and on change and load. And then on change and load, and then you have individual actions. So what we're going to do is we're going to assert one of these. We're going to say like grab me the one whose value is active and click it. And then we're going to assert that when we click that, our to-do list only has one item in it, and that it's not completed. Yeah. So let's do that. Let's say wrapper.find, and here we're going to use this string syntax. And what we're going to do is we're going to use a combination of the display name for the component and an attribute. And we're going to say, find me the bottom navigation action whose value is active. It's going to look like this. Let's go. Bottom navigation action whose value equals active. And then we are going to click it. We don't need to pass an event for this. We don't really care about the click event. We just want to simulate it. Okay. And then we're going to assert a couple things. First thing is we're going to assert that the size of that to-dos prop that's on the nested list is 1, because we passed in 2 and 1's already completed. And then we're going to make an assertion that everything in that map it has it completed as false. Sound good? So let's do this. We can probably let's assign a variable so we can do 2 assertions against it. Let's do const to-dos prop. Let's go ahead and find our simulated list. To-do list. And let's get the to-do prop.
It's modeled after XPath, but it's not, right?
What's that?
Oh, like the active and the search to find it.
Sort of, in the sense that they are attributes on a node in what is essentially an XML document. Yeah, kind of. It's
Language that you learned to use the testing library?
no, actually, you can use that with lots of different DOM libraries. jQuery popularized it at first. In fact, this has more in common with CSS selector querying, a la jQuery, than it does with XPath. But yes, there's some similarities there. By the way, that was like quick digression here. Who was around when jQuery came out? So just real quick, because you have to give credit where credit's due. Like these days, people go, oh man, like we're Procore and we're trying to get rid of a bunch of jQuery code. Like, oh man, all this old jQuery code. In 2006, you had 2 competing major browsers, Mozilla at the time, before Firefox came out, and Internet Explorer. And they had completely different implementations of the DOM, which meant that if you wanted to write code that ran in the majority of browsers, you had to write it twice. And you had to do all these switch statements. If it's Netscape Navigator, do this. If it's IE, do this. It was a real pain in the ass. The most important thing that jQuery did, and this just revolutionized front-end development, was they basically built an abstraction on top of that. And they gave you this really nice, clean API that hid all that complexity for you. That was the most important thing jQuery did. The other 2 really important things jQuery gave us were querying the DOM by CSS selectors, which was so important, actually made it. We now have query selector and query selector all. Thank you, jQuery. And the other was it provided a really nice abstraction on top of the XML HTTP request object called AJAX. which was, again, hugely influential. Like most of the major HTTP libraries written since then followed the template that jQuery put forward. So what's that?
Sorry for the expect.
Yeah, no worries. Credit where credit's due. jQuery was amazing in its time. Absolutely amazing.
Most important thing, because jQuery taught like half of the people who know JavaScript today learned it from jQuery.
Totally.
Because it was like the best learning curve I've seen in my career.
But that was both a blessing and a curse, because you had a lot of people that learned jQuery and then sidestepped all the weird peculiarities that are JavaScript. And it's important to learn those. If you learn those quirks, the language is actually fairly useful. If you don't understand them, it's just like a serious pants on head. What the fuck? Anyway, I digress. Okay, so we've gotten the to-dos prop. Now, what we want to do is we want to verify that not only is its length now 1. So let's do this. Let's insert that first. Expect to-dos prop dot size to be 1. Let's do that first. And then the other one we want to do is we want to make sure that even though there's only 1, and we want to, let's say we had 100 in there, we want to make sure that every one of them has not been completed yet. So we can use, we can do this. We can convert that map into an array and use array.every. Is everyone familiar with array.every? It just passes a predicate. It runs a predicate over every element in the array and returns truthy, or true, if it matches. And it can tell you if every element in the array meets that condition. So we'll do that. Expect, and the syntax looks like this. So all of the, as of ES6, all of the built-in collections, and that includes arrays, you bet, maps, sets, and strings. Strings are just a collection of characters. All of them implement this new iterable interface. And is everyone familiar with the iterable interface? I'm not going to describe it now. I'm just gauging if people know or understand. It basically just lets you iterate over a collection lazily by asking for the next thing instead of knowing its length ahead of time. And there's a couple of different ways to consume it, and one of which is this convenient little spread operator. I know you've all seen this. Anyone that's using JavaScript has seen the spread operator, right? Spread operator will consume an iterable. So what we're going to do here is we're using array literal syntax, and we're going to spread out the entries in the map. So we're going to go like this. We're going to say to-dos prop dot entries. Entries returns also an iterable, and that iterable is an iterable of key value pairs. So in this case, we're going to get a 2D array, which looks very much like this. That's what we'll get back. Okay. And then what we can do is call every on it. So every is just going to run some test against every element in there, and we want to assert that this condition is true for all of them. So the callback is going to give us both the key and the value. So the to-do, and we'll call it is completed. I like descriptive variable names. I think is completed is a good name for that, for the value. Yeah. Okay. And then that callback, we want to verify that it's true for every element in there. So we want to verify that is completed is actually false. Okay. Does everyone understand the assertions that we just made? All right, linter's complaining at me. What did I do? Oh, I know what's wrong. This is going to use array destructuring. So we actually need to wrap it in an array. Oops.
It's not going to give you both of them. It's going to give you an array with 2 things.
It's exactly. It's going to give us an array, and we're going to destructure that into a couple of variables. And I forgot that step. So let's do that. Oops. It is. Darn it. It can't catch my typos, though. I'm looking for a Vim plugin that will autocorrect as I type. If anyone knows of one, please let me know. So yeah, it is. I'm using a package called uCompleteMe, which is a code completion engine. Basically uses a combination of tags and some syntax rules, and then it also works. I also have ESLint and Prettier plugged into this. It's still complaining at me. What's it saying? Unexpected token, comma. What's wrong? It's right here. Yep, that's it. That is it. Still complaining. What's wrong now? No, that is correct. It needs one more. It needs a closing at the end. Okay, we want expect that to be that fixes that one. We got something wrong here. Oops. Okay. And it's going to fail. And it gives us our usual familiar warning. It's trying to simulate an event, but it didn't find anything to simulate on it because we didn't put that bottom navigation in there. Right? Does everyone follow that? So we made an assertion here to simulate a click event on this bottom navigation action. But our component doesn't have that yet. Does everyone follow? Cool. Let's do it. So we're going to need both the bottom navigation. Oops. We're going to need bottom navigation. And bottom navigation action. And then we can, let's actually put some in there. And let's put a bottom navigation action in there. Okay, now, let's see, what do we need for this thing? To make this work, what did we say in our test? We said, oops. We said in our test that we were going to click it. And then we're looking for one with a specific value. So we're going to have to give it a value, right? And then if we go back to the docs for the navigation, bottom navigation, we'll probably need a change handler. Or when we actually click it, what to do with it. Yeah. So let's do that. Okay, so first, let's give this guy a value. And the one we were telling it we were going to click on was active. And then let's give this guy an onChange handler. And let's look at the signature for that onChange handler. I think it gets both an event and a value. So what we're really interested in is just the value. So we'll give it 2 args. We'll just ignore the first one. So that means we need to wrap it in parens, event, in value. Okay, so what we want to do at this point is, in response to that, we want some way of indicating what to-dos we're going to show, right? So probably the easiest way to do that is maybe to hold that in state too, current view. Sound reasonable? And that way, when the function gets called again, we can look at the current view and decide what to render, right? Sound like a good plan? Anyone not agree with my plan? Speak now or forever hold your peace. Okay, that's what we're going to do then. So let's do this. Let's say, let's create a new use state to hold our new state. So let's go here and let's say const, let's call it to-do type and set to-do type, use state, and we'll default it to all. And then in our onChange handler, we can simply use that set state, that set to-do type to use whatever value we passed in. So let's just say set to-do type. Oops. Not that. Set to-do type, and let's just set it with the value that came in. Okay, we're halfway there. We've now got state that says what type should we show. So now we just need to filter them down. So let's do that. So before we actually return this block of JSX here, let's filter these values down. Let's go here and let's say we want to do something. We want to say if they're active, do this. Otherwise, just use the to-dos you already have. So rather than writing an if statement, so I generally don't like if statements if they have else's after them because you end up building lots of else's. Has anyone ever seen like code with lots of else's? Yeah, it's awful. There's a nice little pattern you can use in JavaScript. You just create an object with some keys, and then you take a string and you say, just give me whatever's at that key, right? And if it doesn't exist, that gives you sort of a more formalized interface for doing it. Sort of like a, I don't know, I like using it. It's a good pattern. So that's what we're going to use. Let's call it to-do types. It's going to be an object. And we're going to have a key called active. For now, let's just put it as null. And then what we want to do is we want to either grab the value that's there or use the default. So let's create a new value for what we're actually going to display. We'll call it final to-dos. And it's either going to be the value in to-do types that matches the current to-do type, or we'll just use the to-dos we already have. So right now, we don't want to return null. We actually want to return the active to-dos. So we're going to base ourselves on our previous assumption that may be wrong, that creating a new map by passing an iterable map will create a new one. And we're going to pass the existing map in. We're going to tease it apart using the spread operator into an array and filter it. So let's do this. Let's do to-dos dot entries. And in fact, I'm almost positive that calling entries will give you values. So this should be 100% safe. So this lets us do array manipulation methods like filter. And then inside filter, we can do something like this and only return those values where is completed is false. Or flays. Okay. All right. So now we've got somewhere in state that holds our currently selected bottom action, which in this case is going to be active. We're going to say set it as active. The function will be called again. It'll get to this statement here on line 18 and say, oh, there's one last thing we need to do. What else do we need to do? It's going to get here and it's going to assign the right set, the right map to this final to-dos. What's missing? Come on, guys. Somebody's paying attention. Did I lose you already? What's that? Yeah, that's right. Oops. Let's not do that. Okay.
You've got to do is a few lines above that, but the line numbers are weird. So
yeah, it's on relative line numbers.
Yeah, so like line number 6 at this moment.
Yeah.
In time.
So what that is, for,
That's a different to-dos.
yeah. Hold on, let me see. You know what? Set no rel. Is that it? No. What's look it up for me. Somebody look it up. Vim turn off relative line numbers. But what it is for those who are wondering, in Vim, what is it? RNU.
NORNU.
Okay. Okay. Cool. What it basically is, it shows you a relative line number. In Vim, everything is a motion and an action. So you're basically here, when you want to go up 10 lines, you do 10, okay? And this, instead of seeing absolute line numbers and having to calculate the difference, it tells you exactly what the line number is you want to go to. So if I want to go back to where I was, I just go 10J, and it takes me back down. And then it all shows me the actual line number. So what was it? Set no RNU?
RNU, nor new.
Okay, so now we have absolute line numbers. Is that better for everybody? Okay, cool. All right, cool. Now we should have everything we need for this test to pass. Yeah, look at that. Whose mental reward system's kicking in? Yeah. This is better than all the drugs I did in college combined because I get paid for it. I might have gotten paid for that a little bit too, but I don't mention that in public very often. No, I'm kidding. All right, cool. So now we've got all the active to-dos. So remember we said we'd have a corresponding test that shows only the completed to-dos. Yeah, let's do that. All right. Okay, so what we can probably do is just copy this whole test. And then we'll change the assertion. Only shows completed to-dos. And now we can just reverse our assertions. So first of all, let's change the value of the action we want to click and make it completed. Then it should still be size of 1. And then we can just change this assertion and make sure that everything is completed. Okay? Let's watch it fail. Okay. There's our familiar friend. Simulate is only meant to be run on a single node, 0 found instead. Everybody knows what that is, right? Who wants to tell me what it is? What's wrong? There's nothing that matches that find, right? We don't have anything with a value of completed, right? Everyone follow that? Okay, let's fix it. Okay, should be pretty simple. Copy this guy.
Add that to the dictionary.
And then we're going to add it to the dictionary. That's right. And that should also be a pretty simple cut and paste or copy and paste operation, right? Should be able to grab all these lines here from like this. Now I've got a math, man. Now I've got to do 19 minus 15. You guys are messing me up. Okay. Now we can just do this, and we could probably even dry this up and make this the conditional on either side a method, and you pass it whether you want it completed or not, right? But we're not going to get that dry. Okay, now, oh yeah.
Is it so slow?
Huh?
Why is it so slow? Yes, it's slow.
You think that's slow?
3 seconds.
Yeah, that is pretty slow. That is pretty slow. It's probably because, my guess is, it's because it's using mount, and it's actually standing up the JS DOM. Shallow tends to run a lot faster. So, and
3 seconds first test.
what's that?
I think it's been about 3 seconds first test.
Yeah.
It's a user error.
Yeah, there you go.
It's just like it's just standing up the test framework. So like you can add a bunch of tests, it'll still take about 2 seconds.
No, actually, that's not the case. This is running in watch mode. So the test runner is already running and it's watching your files on disk. If I had to venture a guess, it's because of mount and JS DOM. If you're running in shallow, it should be faster. But what's funny is if you were to run this, say, for example, with Jasmine as a test runner, it would probably be at least 1.5 to 2 times slower. The one thing that Jest does, and it really pays dividends when you have lots of specs, is it parallelizes them. It's because Node manages a thread pool. It'll actually split your test files up and then partition them to different threads. And it'll actually spawn the Jest runner in separate threads. And then it really speeds up. Like in CI, for example, Jest really shines for that. But yeah, 3 seconds is a long time just to run these tests that we wrote and the app test. The app test also, in fact, you know what we can do? We might be able to do something like this. Let's constrain this just to to-dos and not run app. It's still parsing them all. That makes it faster because the app test actually does React render and stands up a full element as well. So that cut it by 1.5 seconds almost. So better. It's an improvement. Yeah. Okay. One last thing that our to-dos function needs to do. Does anyone remember what the last thing before we dive down into the list? By the way, the next 2 components, the list and the to-do thing itself, are going to be a lot faster than this. I would normally do it the other way around. I would write the to-do first and then write the list and then write my container. But this is an equally valid way of doing it. And in fact, this method is great when you understand the requirements or you have complete requirements. You can do like discovery testing where you can start at the top, the stuff you do understand, mock things out down below, and then work your way down or work your way from both sides to the middle. Does anyone remember the last thing this thing needs to do? We can add a to-do. We can initialize with to-dos. We can show only the active to-dos, show only the completed to-dos. And we probably want to make sure we have one that can show back to the active, but we'll skip that test for now. But there is one other distinct functionality we didn't do yet. What happens when it's next year and we have 5,263 completed to-dos cluttering up our list? We want to clear those, right? Yeah. Ryan gets it. Ryan gets it. I'm fighting that at work right now. Developers want the newest shiny toys.
Also deleting it. Let's just say you make a mistake and enter and do something else about deleting one.
That'd be totally valid. That would be totally valid. I didn't. Yeah. I'm going to take your suggestion under advisement for version 1.1. That's cool, man. That's good. See, you can never really appreciate the implications of your design until after you ship version 1, which is why Agile has been so valuable, because you can actually get real world knowledge of your software instead of spending 3 years building it based on requirements that inevitably have changed in those 3 years. Anyway, long story short, let's add one more thing, which will clear our completed to-dos. And for that, that's a discrete action. It doesn't really belong in that bottom navigation. We can end up at the end, when we style it out, we can make it look like it lives there, but really it's more of a button. I think it's a discrete action versus setting the state of something. So let's go ahead and assert against a button. Let's import that. Actually, we don't need to import it. We can do a display name test again. So let's do this. Let's go ahead and just grab all of this test again. We can do that. And now I've got a math again. Oh, my relative line numbers are back on. You guys are okay with that, right? Makes my job a lot easier. Cool. Okay. Now it clears completed to-dos. Okay, so now we've got 2. Let's get rid of this. Actually, we can just substitute this for a button. We're just going to make this, for now, we're just going to make an assumption that there's only one button. We probably want to get more sophisticated with it. Maybe like wrap that in something that has a name and just renders out the button so that we can assert against that, but we'll keep it simple. We're going to simulate a click on that button, and then what we want to assert is that, again, we started with 2. 1's completed, so our size should be that. And then let's change our assertion to make sure that everything that's left is not completed. Remember, our default state is all. When we initialized our to-do type here, the default is all. So we don't need to do anything. We know that when we start this thing up and pass it to to-dos, it's showing everything, right? Cool. Okay, so looks like a reasonable test to me. We're going to find our button that clears all. We're going to assert that then we're only left with 1 and that it's not completed. Yeah? Do we agree? Let's do that. And then there is one more test, I think, that we need still for this component. Let's implement this one. Let's go ahead and import our button. Come on, Vim. That's better. Okay, and then let's render that. And then let's give it an on-click handler. And then in our on-click handler, we want to reset our to-dos, right? So let's create a copy.
Are you closing your bracket too soon?
I am. That is my one of my key bindings being helpful for me, closing that bracket, and me not remembering to get rid of it. I have it basically auto completing anytime I open parentheses, open a bracket, open curly brackets, etc. And let's create a new map. And then we can do the filtering inline. So we'll grab our entries, and then we will filter them. And only grab those that are active. And then make that our current set of to-dos. Okay. Ooh, syntax error. What did we break?
Got one more trace that you need.
Yep.
Curly brace that you deleted.
Yep, that's it.
Can't you just call filter right onto the map?
Hmm?
Can't you just call filter right on map?
Map does not support filter.
What does it?
Nope. Doesn't support any of the array methods.
Oh.
But you can spread it out and then use them.
Yeah.
Yeah, map does not support any of those. We're getting a little warning from the button object saying that it requires children. It's just a matter of putting some text in the button. So let's do that. Other than that, the test should pass. Okay, there's something missing. Something missing. We can add a to-do. We can initialize to-dos. We can clear the list of completed. We can show the completed ones. We can show the active ones. What we can't do is complete one. That's a problem too, right? Because you'd have 10,643 open to-dos, and you'd look like someone who never gets anything done. So we do need to be able to toggle them, right? And just because we're storing the to-dos here in this component, not in the component that's responsible for rendering it, that might actually handle the click, we're going to need to be able to toggle them. Yeah, do we agree? Okay, let's do it. So okay, let's do this. It toggles it to. Okay, so we've got a couple to-dos. Let's go ahead and toggle one of them. So what we can do is we can pass our to-do list a toggle callback. And it, in turn, will pass that down to the individual to-do renderer. We don't really care about that plumbing. All we care about is that when that callback is invoked with the key for a to-do, that it toggles it in our list and passes it back down. Yeah? Does everyone agree? We don't want to make assertions about anything further down in our component tree, just this unit we're testing.
Since it's about testing, are you okay with toggles? Because then if you're not keeping track, you might get toggled twice, and then you can't figure out how it went from true to false and then back to true.
We don't care. It can only be, it's a mutual exclusive state. It can either be true or false.
Well, yeah, but in a complex application, like if you're trying to run a state, like telling it explicitly, mark this is done, mark this is not done, it's going to be more reliable than just telling it to toggle the state. Because if it's...
How so? Does it matter in a to-do list?
No, but...
No, it doesn't, right?
Not until it gets a little bit more complicated. And then you have like...
Totally agree. Here's another guiding principle for all software development, right? Yeah. Only reach for complexity when it's warranted. Right? Yeah. All other things being equal, you've all heard of the acronym KISS, keep it simple, stupid. It doesn't mean you're stupid. It means that human beings are not good at handling complexity. So it's based on Occam's razor, which is often misquoted, but the general idea is that all things being equal, right? All other considerations being equal, the simplest explanation is usually right. And that applies to software engineering. If you're tackling a problem, start simple. Always use the simplest possible solution that solves the problem at hand, and only reach for complexity when you can't solve it with a simple problem. And usually you build complexity by composing simpler solutions. So to your point, in a more complex application, absolutely being explicit would help. But in a to-do list, all you care is that at any given point, a to-do is either done or not. And you can toggle it, right? Because you can say, oh, thought that was done, but I forgot to call Jim and confirm it. So take it off, put it back in to do until I'm done with it. Or, you could have like an in progress column, like a Kanban board or something, but we're not, again, this is a simple solution. It's either done or not. It keeps it really simple. And it also makes the application code really simple. Mutually exclusive, it's on or off. We don't care about anything else. It's on or off. Fair? Does that answer your question?
Yes.
Cool. All right, totally agree though. So in order to do that, we don't actually want to implement the toggle function. I guess we do in this case, don't we? We could pass it to a spy and make sure that it was called, but that doesn't tell us that it was actually set. We'll get to mocks in a minute. Instead, let's do this because it lives internally. Let's go ahead and find our list. And let's grab its props. And let's call an as yet non-existent on toggle with callback. Okay. This is taking longer than I thought. I apologize. Do we have to be out of here at 9?
That's okay.
Okay. Are you guys cool to hang out for like another 20 minutes, half an hour maybe? We could probably rip through this whole thing. If not, feel free to bail. Or just tell me to stop. Tell me you're tired of me sitting up here yapping at you, and I'll stop. So let's call untoggled. And untoggled, because we're using a map, and we know we can toggle something just by giving it its key, let's just say we'll grab the first one in there and pass it foo. Okay. Now, what we're going to expect is that if we go then and get our to-dos prop on our list and get the value at that key, it should be the opposite of what we have initialized it with. So let's go ahead and expect that if we grab our list and then grab its to-dos prop and then use the get method on the map, so let's get foo, we should expect, since we've just toggled it, that it should be true. And let's see what happens. Untoggled is not a function. Makes sense, right? Because we haven't implemented it yet. So let's implement it. It's going to be on this guy. Okay, untoggled is going to take a to-do. We'll make our as yet undetermined copy of to-dos. And then we can say new to-dos.set to-do, and we'll make it the opposite of its existing value. Then we'll use our state helper. And see what happens. It failed. It's interesting. Almost all of the other tests here that manipulate state using that state helper actually work and provide back the same state. And this one, and I'm going to go ahead and use one of the most important things I learned in software engineering. I don't know why I have to call wrapper update on this one, but forcing the thing to re-render makes it work. So let's do that.
That's something you fix in your test or something in implementation that you change.
Unknown. I'm going to force it to re-render. I spent a little time looking at it and didn't come to a satisfactory answer. If I figure it out, I'll post a comment on Meetup explaining why. But for now, suffice it to say that the magic of enzyme makes this test pass. and we can ship it. It's kind of like, sometimes you come across comments in the code. I don't know why this does this, but don't change it because otherwise production will go down. It's like that. And you want to find that person and strangle them. I like, there's one of my favorite quotes in software engineering is by a guy named Martin Golding. And it is always code as if the guy who ends up maintaining your code is a violent psychopath who knows where you live. Okay, now our to-dos component is done. It's good. That unit is. Nothing inside of it works, but it's done. Now we can go, let's go ahead and create our list. We'll try and do this as quickly as possible. Let's do this. Let's open up our tree. Let's create a new one that we've already named. Actually, we have the file itself. It has nothing in it. Let's create the test. Okay, now let's go ahead and actually, you bet. Thank you, Elijah. All right, let's do this guy. Okay. Okay, again, we don't need before and after each. We'll just get rid of those. What we do want to do is we want to display a to-do for every item in the list. Yeah? Sound good? Cool. Let's create a to-dos list. Let's create some to-dos. Okay, let's pass those. Now, in order to do this, we're basically going to do the same thing. We're going to pretend that there's a to-do component, and we're going to mock it out, right? And all we really want to do is say how many got rendered, and did they match? The number match, right? We'll write one test that says if we give it 2 of them, we should get 2 as yet uncreated to-do items. And then we'll write another one that says get a random one and verify that its props match the data. That should be sufficient for this guy. Not a very complicated test. So let's do this. We're going to need to mock that. So let's create it first, because Jest requires that we actually have something on disk. Oops, let's go. Let's add something. We'll call it to do. That'll be enough for it to be imported. Let's go ahead and import it. And then let's mock it. Okay. Now we can just assert on that thing. Let's do finds. And then instead of checking whether it exists, we're just going to see how many there are. We're going to just make an implicit assumption that it actually exists. And it's going to fail. Ooh. Can anyone tell me why that passes? Because we're only running the other test. Let's fix that. Okay, now it fails. And now it's telling me, for some reason, it looks like it is not respecting our mock. Let's see, why not? That should be legit. Oh, our actual component itself has nothing in it. That's what the problem is. Let's fix that. Okay, let's import our to-do. And then we should just be able to map over the to-dos, pull out its entries, map over them, and render one for each. And that should be enough to make that pass. Let's get rid of prop types. That's just noise for now. Okay, so we're going to destructure. And then for each one, we'll render out a to-do. Because we're rendering out a collection, React really wants to know the individual identity of each one so that when it does that reconciliation, it knows whether or not to replace something. So it asks you to give it a key property. And since we know every element in our map has a unique key, we can just use the to-do as the key. And then we want to-do to be the to-do as well. And then lastly, we want an is completed. Okay. Yep. Still got something wrong. Was it like unexpected token driver? And I need one more here, right?
Oh, you don't have an open curly.
No, that's it. You don't need it. We're basically returning a JSX expression, and we're just we're explicitly stating that's an expression by wrapping in parens. Anytime you want to tell JavaScript that something is an expression, wrap it in parens. That lets you return multi-line JSX from the right-hand side of a return. It can span multiple lines because it's JSX, and you just tell it this is an expression, wrap it in parens. So you'll actually see lots of React components written this way as arrow functions. It's just an arrow function, and the right-hand side is just open close parens with just JSX in it. Again, I don't recommend that if you're writing standalone components, because chances are when you're debugging, you're going to want to put something before you actually return and see if your props. Anyway, long story short, here, this is both an excellent use case for arrow functions because it's a callback on map. Arrow functions were really designed for terse callbacks and to retain the value of this from the lexical scope. And then it's also an inline map. So it's a little bit terse. Anyway, that should be enough to make that test pass. Cool, it passes. All right, one last test for this component, and that's going to be to verify that at least if we grab some random element in the map, that it has the right properties. So let's say it provides the right data to a given to-do. Let's do the same thing. Now what we can do is we can just go grab, say, the second of these to-dos and verify that its value, that its to-do text is bar and that its value is false. Sound good? So let's assign it to a variable. Or call it something really descriptive like to do at 1. An enzyme gives you a little shorthand. It does return an array, but if you want to be explicit, you can do something like this. Find at the index. And then we can say to do at 1, we'll get its to-do prop. And that should be bar. and its value should be false. Or fouls. Cool.
Wait, was
Done.
That one ever read?
Huh?
Was that one ever read?
It was.
Oh, okay.
It was. Okay. And in fact, we could have satisfied the first test without even passing those props, and then this test would have been read. But that's a good call out. All right. We've only got one more component to go, guys, and it'll only take like 10 minutes. And then we'll get rid of all the mocks and watch the whole thing work. And then we'll pull up in the browser. We won't have time for the styling part because I want to get you guys out of here before 10, but you'll get the picture. All right, cool. So one last one, and that is the actual to-do component itself. So we're going to need, I think, a new test. And this one will at least be able to illustrate just mock functions. Okay, so what do we need to verify on the individual to-do? It shows the to-do text. It has a toggled indicator, and that it responds when we click the toggle indicator. That's pretty much it, right? Sound good? So let's say it displays the to-do text. Okay. Now what we can do here, what we want to do, let's pass it a to-do. Actually, and then let's assign it to a variable first.
Thank you.
You bet. Thank you. All right, let's pass it that to do. And then what we want to do is, remember earlier I said it's generally not a good idea to assert against some specific markup. There's a nice little utility that Enzyme provides that lets you find something based on a predicate, based on some condition, right? So one of the nice things you can do, if you just want to verify that a piece of data is being presented, you can write an assertion that says, find me at least one node whose internal text is exactly this piece of information, right? Or his internal text is exactly some number coursed to a string, right? That way, it doesn't care whether it's a span or a div or a p tag or a bold or an aside or whatever. So let's do that. That lets you do extensive visual refactoring on it without breaking. So let's do find where, and find where takes a callback. It's a predicate function that accepts a node, and it will run this against every node in your tree. And then you tell it some condition that should be true if you want it to come back. So we want to say where node.text is exactly to do. And right now, we know it's going to fail because we have nothing in that. There is no React element. So let's fix that. So now we should just be able to do something like this. We should actually just be able to wrap this guy in the div. And then write out props.todo. That should be sufficient for this to pass. Now we could wrap this in all kinds of other markup. And in fact, if we put like a layer 10 deep or put a whole bunch of other stuff in here, including other text, but with no text, if we put, say, a div and then put a span and put some other stuff, all of those nodes would match. They would satisfy this test. But as long as there's at least one that has only that as its text, this will pass. And the minute we start putting other text outside of it, it'll fail, right? But this lets us have a contract that we can respect, and we can refactor the look and feel of it. Let's make sure that this passes. It does. We're green. Cool. And now we have one last test on this guy. And that is, actually we got two. We need an indicator. So we're going to reach for material UI again. And grab a checkbox. And we'll just assert that there is one of those and that it indicates the right information. So let's grab Oops. Shows a completed indicator. So let's go here. We don't necessarily care about the to-do, but we do care about is completed. And let's make its value true. And then we can find that guy. And then it's going to have a prop called checked. And we want it to be true. It's going to fail because we don't have a checkbox. Let's fix that. My relative line numbers are off. It's really throwing me off. Okay, now we're going to have to wrap this all in something else. Otherwise, our first test is going to fail. So let's do that. Okay, and let's do that again. Okay, now we can add our checkbox. And then checked can be props dot is completed. Okay, we're almost there, guys. Bear with me. We're almost there. Okay, cool. And then the last thing is we just need to be able to respond when they click that checkbox, right? We don't need to do anything. We just need to respond, right? In which case, for our test, we don't even need to actually implement the callback. All we really need to do is verify that some callback gets called, right? And to do that, we're going to, wrong test, sorry. To do that, we can use a mock function. And you'll notice that all of my tests have language that reads the way a PM could understand it, or a client could understand it, right? That's on purpose. You want to write tests that describe the behavior, right? Like always avoid using the word test in your component, avoid method names, avoid object names. You can use it in your describe block, but what you really want to do is just describe the behavior. You're testing an interface, not an implementation. Super important. So let's go ahead. All we really need to do is render it. We don't really care what's in it. We probably do need the to-do so we can verify that our mock was called with it. Let's go ahead and render it. We'll just give it some hard-coded text. What we're going to do is we're going to use a mock. Everyone know what a mock is? Anyone not know what a mock is? Cool. A mock is, there's a couple of different things you'll read about in testing. Let me just type this and I'll tell you what they are. Mock, stubs, and spies. A mock is just what it sounds like. You're mocking something. You're basically, you want to create a stand-in for something. It doesn't actually do anything. It just behaves like it's the real thing. So in the case of jest, a mock function is basically a function that can be called. And then more importantly, it lets you then make assertions about whether it was called, how many times it was called, what arguments it was called with. It just doesn't actually do anything. A spy is just like a mock, only it actually calls the real thing. So it wraps a real thing. That thing is actually invoked, whatever method it is, and it adds the hooks that says it was called with this many times. And then the last thing is a stub. A stub is like a mock that does something. So it's the case where you want something to stand in and you want it to behave a certain way. That's not the real thing. So a common use case for that is like API requests, right? You want to make an API request in a test. You don't actually want to go across the network and wait for it to come back. You just stub the response. Just in Jest, a stub is a mock with an implementation. But basically, jest.fn returns a mock function. So now we can pass that, and then our component can call it. It just doesn't do anything except let us know that it was called. And so what we want to do then is we want to find that checkbox. We'll find
this, but does the mock makes an assertion that it was called, right?
the mock exposes a function, exposes some hooks that let you know whether it's been called. Yeah.
But it doesn't implicitly do it for you.
It well, you have to invoke it. You call it. It's just that it's a mock function. It doesn't do anything in the context of your application. It just sits there and has some wrappers.
In context of your spec,
Mhm.
It doesn't say like, oh, this was expected to be called, but it never was.
Only if you assert that. So you assert, you say expect mock function. We'll see. We're going to say expect the mock function to have been called with, and we're going to expect that it's called with that to do. So we're going to find the checkbox, and then we're going to simulate a click. Okay, and then we're going to expect that our mock, and we'll have to pass the mock as well. We're not actually passing it right now. We're going to expect that it has been called to have been called with doing it. And of course, in the real world, we would assign that to a variable. Oops. But let's actually pass it to our component. Untoggled equals mock untoggled. And it's going to fail because we don't have a handler. Okay. Let's fix that. And it's actually the function, the callback that you get on a click with Material UI with this component is actually unchanged, not on click. Doesn't match, but that's okay. Change equals, and we are going to want to, actually, we're going to want to call and then we're going to call props.ontoggled with our current to-do. Did I break it?
Auto brace closed you.
Darn it. Oops, that's not it.
Yeah. And then we probably have to add one at the bottom.
You are absolutely correct. Still complaining? Nope, it's good. What's wrong? Okay, and what happened? It was not called. Why was it not called?
So we have like change rather than all.
Yeah, you should be. Let's go ahead and simulate change. Cool, look at that, all works. Okay, now what we can do is this. Now we can get rid of this mock because we have an actual to-do component and our tests should still pass.
Don't we still want the mock though, because it encourages, like, it enforces loose coupling?
Potentially, although in this case, we're using shallow. So we don't actually render out the internals of to-do. All we do is render just what it looks like and its props. And more importantly, by using the mocks up front, we enforced testing only its public interface. So our tests never actually reach in there. Now we can keep that contract in place by only testing the public interface and actually put the real thing in there, and our test should pass. Right? And then we can do the same thing with our master to-dos. We can stop mocking the list, and the test should still pass. Now, in reality, I would probably stand all these things up. And in this case, we sort of have an integration test because our top level container does everything. Let's do one last thing. and let's just make it look like shit in the application itself. Let's go to app and let's import it. And then let's just put it right in the middle here. Okay, now let's run it. And what we're going to see is there's going to be things missing. So, like for example, we didn't put labels on our bottom navigation. So those things are actually here. We just can't see them. See my mouse is hovering over here? It works. It works though. Watch. We're also not clearing out the text. Right? So there's things like a set of unit tests isn't going to capture everything, which is why integration and end-to-end testing is really good. That's another form of automated testing that catches things. Problem is like end-to-end testing is expensive. But if you use it judiciously, it can save your manual QAs for doing things that are harder for machines to do. But let's go ahead and add a few. And you can see like it's all formatted poorly, right? But,
They're not side by side.
oh, look, something's broken. What do we do? Props.toggle is not a function. Oh, we missed something. We missed something, right? What did we miss? What did we miss? Can anyone guess? I know what it is. We didn't write a test here to verify that we're passing our untoggled through. Right? Yeah, I am. I'm totally fired. But you know what? We still caught this bug in development. So it's 15 times less expensive to catch than in production. Fucking A, man. So what you need to do is just pass this. And this is the reality is that even with the best TDD, you're not going to capture everything just in your tests. But you'll get to the point where the thing is mostly working. You've caught most of the stupid mistakes. So let's just pass it props.untoggled. We know we have this because we tested this in our to-dos component. And that should get us the rest of the way there. Okay, let's try it. Let's just try one and make sure it completes. Look at that. Brilliant. Cool. Now, watch this. So we can't see it here, but somewhere here, there's active, right? There's only active. And then here, somewhere here, there's like all, no, we just have active and to-do. There's completed, right? It's cool. Let's fix that real quick, just real quick. Let's go to our to-dos. Oops, not that one. And let's just do this. If we do this, if we had a flag here, show labels. And like this is the stuff you do. This is like visual refactoring, right? At this point, you're going to make sure it works. This is potentially, this could be considered behavior too, because we didn't specify the right props. But let's just add label. And ideally, we would want something that shows all, that resets it. Active. And then let's do the same thing here. And then these will actually show up and make the UI a lot easier to use. And the way I would usually do this is I would keep the tests running also in one window while all this is happening. And that should have, there we go. Now they actually show up. Now we can actually see these. Look at that. Works. It works. Now watch this. Let's refresh it because we don't have a toggle for all, just so we can show that we can actually complete some. Okay, let's, ready? Ready? Okay, I'm gonna let you guys go because it's already 9:30. What we would normally do here is we'd leave all the tests running, leave this thing in watch mode like this, and we'd start styling this out. We'd put it in like a nice paper, elevated and stuff like that, right? So what do you guys think?
Great.
All right.
Yeah.
Thanks for showing up. Really appreciate your time and your patience, guys. Next month, I got nothing. I had like an informal conversation after the last one where somebody made a soft commitment to speak, but I don't remember who it was.
It was me.
Yordis, I'm putting you on the spot. You're speaking in January, yeah? Right? First Monday in January? Okay, that's a soft yes. Soft yes. That's a soft yes for Yurdis. Speaking on TBD topic, TBD speaker, TBD location, but it will be the first Monday of January. We need help getting speakers. If you want to stand up here and dazzle everyone with your JavaScript knowledge, you too can stand here where I stood tonight. If you know someone who wants to speak, if you're interested in being speaker chair, that would be even more awesome. I just want to give a special shout out to Garvin, who's been my co-organizer for the past 3 years. Without him, none of this would have been possible because nobody else wants to step up and help. Please help. These things don't run themselves. With that, Happy New Year, happy holidays. See you guys next year.